assume that semicircle is right here. So if we rotate that around, we are going to end up with a sphere. Okay? All right, what about a rectangle? A rectangle. We're taking a rectangle, so here's my rectangle. And we rotate it around one of its sides. So let's say that we're rotating it around this side right here. So I'm going to keep it still, and I'm going to go around that side. Okay. Now remember, this does have width. I know that it gets kind of flat there on the outside, but if I turn it over, it's very short. But what kind of figure is this technically? A cylinder. Very good. Okay. Circular base. It's got some height. Okay. Like I said, I know it gets kind of flat there out on the ends, but it does create a cylinder. So very good on that. There is an app here that does this as well. We can rotate a rectangle. This one's a little different than what I just showed you. I rotated it around the short edge. Okay. If we rotate it around the long edge, thank you. When you open this and click on the rectangle, this button right here above the XYZ axis, if you drag it, it will spin that rectangle around. So you can pretty much see at this point that it is a cylinder, but if it was a little unclear, you grab that little red button and you can drag it and it moves it around, and you can see that is indeed a cylinder. Okay, we did the circle. Now this one takes a whole circle, but look, it's rotating it around its center. Okay, it's rotating it around its center. So it's the same difference as rotating a semicircle, but you can see that is indeed a sphere. Okay, let's go back. What about a triangle? What do you think a triangle is going to make? Before I click on it, we rotate a triangle. Come. Yep. Okay, here's a triangle. We're going to rotate it around this side right here. So if I spin it around, it does indeed make a cone. Okay. So this one is a little bit more limited. There's not a whole lot of manipulating you can do to this app compared to the other one, but it does a good enough job of showing you those three-dimensional shapes that are created. Okay, so far the questions that we've asked and answered have been pretty basic in terms of these questions, but I have seen them go a little bit further with them. So this one takes a little bit further. What three-dimensional figure is created by rotating a rectangle with vertices at 3, -4, 3, 1, 6, -4, and 6, 1 around the y-axis? So anytime I'm given a problem like that, I am most definitely going to draw myself a sketch. I need a good idea of what this is looking like. So 3, -4, 3, 1, 6, -4, and 6, 1. There's my rectangle. And I'm going to rotate this around the y-axis. Okay? So we already established that a rectangle is going to make a cylinder. But the way that we did it, we kept that axis fixed, and it was touching what we were rotating around. This rectangle is not touching what we're rotating around. There's this gap right here. So maybe I can make this work. Okay, I did it earlier, but we'll see. Okay, so picture, well, mine's wider than it is tall, but just imagine here. Okay, we're rotating it around this line right here. So if I pull this out and go around that line, pretend that that's not falling apart right there. Let me do a little magic. Hang on. I want to get it right. Okay, so I went around that line and came back to where I was. Okay, so what would you say the shape is that you're looking at? Cylinder, but what's in the middle? There's a hole, because there was a gap beside the side of the rectangle and the axis that we were rotating it around. So it's going to create a gap in the middle of our cylinder. This is like the problem, oh, forget that. It's like the problem, it worked better than it did earlier today. It's like that example we looked at right here, where we had the cylinder with the cylinder missing in the middle, okay? Can you kind of picture that if I cut right here, I would have a little rectangle, and if I rotated it around that fixed point right there in the middle, that's going to create this shape. So we've got a big cylinder with a cylinder-sized hole missing from the inside. So let's go back to our question. What figure is created? Well, that's a cylinder with a hole. Okay. What would be the height of this cylinder that is created? What would be the height of that cylinder that's created? Well, we got two numbers, right? We got from here to here, and we've got from here to here. So side to side, what distance do we have? We were at 3, 1, and then this is 6, 1. So how far? 3. Yay. All right. Height? 5. We were at positive 1, that's at negative 4, so we have a height of 5. So is the cylinder 3 units high or 5 units high? 5, because we rotated around the y-axis there. So the height is 5. So let's work on the volume. Okay, let's work on the volume. So the volume of the outside, we're talking about cylinders, so it's pi r squared h. What's the radius of the outside cylinder? Remembering, we've got to start here and go to the outside. What's that? Excuse me, what's that radius? We're going to start on the y-axis and go all the way to the outside. 6. These points were, the x-coordinates of those points were 6. So that radius is 6. Whoops, I know h. So we've got 36 times 5, 180. Okay, let's find the volume of the smaller cylinder. What's its radius? Bless you. The piece that, bless you. The piece that we take out right here. 3. And its height is the same. It's still the same height. So 3 squared is 9. 9 times 5 is 45. What are we going to do with those two? Add them or subtract? Subtract. We're taking that, we have a hole. We're missing a piece. So we're going to subtract. So we get what? 135? 5? And 135 times pi, I did it earlier, 424.1. Now, since we're in the XY axis, we don't have units, we don't have inches, we don't have feet, whatever. So technically, we really don't have units here, so we'll just put units cubed. When we don't know what they are, we just call them units.